Hello world, let's check out day 8, the 30-day LeetCode coding challenge. I have a feeling the problems are going to move into the medium level around now. We'll see. Okay, middle of the linked list. So we're finally getting some alternative data structures. Let's see, we have middle of the linked list. Given a non-empty singly linked list with head node head, return a middle node of linked list. If there are two middle nodes, return the second middle node. So, problem given a non-empty linked list singly with head node head, return middle node from linked list. If there are two middle nodes, which means the length is even, return the second of the two. So like, let's say we had length of 6 divided by 2 is 3, which if we had an array like this, 0, 1, 2, 3, 5, would return 3. And if we had length 5, which is odd, we would do divided by 2 is 0, 1, 2, 4. That would give us there. Divided by 2 would be 2.5, which would round up. Okay, I'm getting caught in the weeds here. I'm gonna leave that for now. Make sure I understand the problem. So basically, obviously, if the length is not even, you just return the one directly in the middle. So that would be the length divided by 2 rounded down. Divided by 2 would be 2.5 round down to 2. Getting a little ahead of myself though. Let's focus back on the problem, make sure we understand it. So the linked list is singly linked, which means that let's say n is our node. It only connects to the next node. There's not a two-way linkage. So this right here is single, and this would be double. So each node has a reference, except for the head, each node has a reference to the element, to the node before it and after it, with the head node pointing at its previous, which is null, and then the tail, which is the end of the linked list, would point at null as its next value. For the purposes of this singly linked list, it looks like we have a constructor function for list node. We have some state in it. We got this.val, and this.next is by default null. So we'll know, once we're done going through the linked list, we'll know that it is done when we hit null, which means there's no more values. Okay. Let's go to their examples. We have 1, 2, 3, 4, 5. That gives us 3. Because 3 is the middle, but we're not just returning the value of the node. We are returning the node and all of its, and the entire list after that. So that node on, this is the entire list after and including that node, including that middle node. So the entire list, including the current node, and everything past it. And we also have 1, 2, 3, 4, 5, 6, which yields 4, 5, 6. And that's because if there are two middle nodes, like there are here, we've got 4 and 3, we choose the second of the two. Okay. Those make perfect sense in general. So data structure, obviously we're working with a linked list here. You can either use recursion to move through a linked list, or you can use iteration. For the purposes of this question, I think iteration will work better. So let's just say a while loop and array for storing nodes. So we'll know the only way we can find out what the middle of a linked list is without it having a property which states its length is to go through it once. So we're already at linear time with this. It's going to be more than, well, it's going to be just about linear time, a little more than it, because we have to go through it, and then we have to do one more operation. So we'll go through the linked list entirely, get the length of it, and then we can figure out what the middle value of the entire, like the middle index would be, and then we can return whatever node is in our collection of nodes at that index. So from the beginning of the linked list, we can start pushing nodes, the current node, to that array, and then at the next node, we can push that node into the array. So there are separate indexes. So then by the time the linked list is completely traversed, we have an array of the same length as the linked list is. So then we can return the index, which represents the length divided by 2. So we're going to need a counter to keep track of the length. Actually, no, we don't need a counter to keep track of the length, because the array's length itself will be the same as the linked list length. So we don't need that. So our algorithm essentially is to create empty array, declare node head as variable, pointing at, what's our input here, at head, while head is not equal to null, because we don't want to include the current node if it's null, because that means there is no node. While the head is not equal to null, push the current node to the array. And then the trick with traversing a linked list is to assign the variable that's pointing at the head. We will assign node head to node head.next. So then on each iteration of that loop, we're assigning node head to the next node, and eventually we'll get to null, which means the linked list is done. And then we'll break out of the loop. So reassign node head to node head.next. Because as we've seen here, this .next represents the next node in the list. Then we're going to return the array, and then write out length -1 divided by 2, something along those lines. Let's think about how we want to do that. So for an even length, Maybe we don't want -1. Okay. So for an even length, we have array.length. So in this case, it would be, we'd have an array of 6 elements. So divided that by 2, we'd get 3, which is element 4, which is the correct node we want to return. But if we did that same thing with an odd length array, we would get 5 divided by 2 is 2.5, and we don't want to use an index that is a float, so we would round that down to get index 2, which is 3, which is the right number. So if array length is even, return array.length divided by 2, and then else return array, we'll do array math dot, I think it's floor, yeah, floor to go down, array dot length -2. That looks good. Okay, let's try this out. Let results, let nodes equals empty array. Let node head, we'll say current node equals head, while current node is not equal to null. And then so nodes.length modulo 2 is equal to 0, which means it is even. If it is even, we want to just return nodes.length divided by 2. And then if not, we want to do nodes math.floor nodes.length divided by 2. While current node is not equal to null, we want to nodes.push current node, and then current node equal to current node dot next. So we're reassigning it to the next node. Let's see what we're getting just off the start. Oh, I have to return that. Okay, nice. Let's try it with the even test case. Nice. And let's try it with even longer test case. We'll try it with a single test case, and then we know it will be empty, so we don't have to check for that. So we'll just do a smaller test case like 1 and 2. Excellent. So in this 1, 2, I included this edge case because there's only 2 elements. And if we have an even amount, we want to pick the one after the actual middle of it. Well, not the actual middle, but if there's 2 elements, we want to pick the one on the right. So 2 would be the one on the right here. So we got the right result there. Looks good. Let's submit and see what we get. Excellent. Great. 88%. Pretty good. Thanks, everyone. Have a good day.